We're going to finish section 7.4, which was about percents and interest. And we had left off with just having defined some of the pieces that we needed to talk about interest. Oh, that was it right here. And so all of these pieces right here were necessary at different components of defining things. So we talked about interest being the money that you make or earn when you borrow or lend money. P is the principal, it's the money you either put on deposit or the money that you borrow. Your interest rate is the value R as a decimal point. There's two ways to write simple interest, and then we have one formula for compound interest. And compound interest actually calculates interest on your interest, or interest on the remaining value of a loan, something like that. We've done one example with a company that is expanding its line, and they had this very large interest rate of 13.5%, and they paid a whopping total $64,800 in order to borrow this money. So we're on the next example, I believe. Johnny and Carolyn. All right, this couple has 3 savings plans that are going to accumulate. And they're going to accumulate, it says, for 1 year. So that's an important piece of information. All right, the first account is a passbook account. It makes $53.90 on the principal of $980. They have a CD, that's a certificate of deposit, which is much like a savings account as well. It makes $55.20 on a principal of $600. And then they have a money market, which makes $158.40 on a principal of $1,200. And the question that we're actually asked is which one pays the best interest rate? Okay, on which one did they make the most money, in other words? Do you guys follow the question? This question, while it is related to interest, is actually far more related to what we did with percents than it is to the interest itself. What we're wanting to know is we're wanting to know the percentage rate that they're getting. So what is the rate? Well, to do the rate, we don't need those formulas for interest. What we can actually do is we can actually figure out how much they made on what value to figure out their percent rate. So let me show you the first one, and then you guys can walk me through the second one. So for the first one, they made $53.90. They started out with $980. And what we're going to do, just like we did last time, is we're going to figure out what interest rate that is out of 100%. Remember setting up these proportions last time? Yeah? Okay, so how do we solve this particular equation? You cross multiply. So you end up with 980R equals actually 5,390. And you can grab your calculator to do the division. What in the world is your interest rate? What was it?
550.
So, like 550?
No,
0.5? Okay.
or 5.5.
Like this?
Yes.
Okay, good. 1 decimal is enough for our discussion, so I'm going to write it as 5.5%, and if we need to do any rounding on any of the others, we'll do that as well. So this is a 5.5% interest rate on the passbook account. But we can do this on any of the accounts, and it works in the same way. So let's give it a shot on the CD. So what will I write?
5520 over 600
Mm-hmm.
equals R over 100.
Right? 5520 over 600 equals R over 100. And again, we'll cross multiply. So this will be 600R equals 5,520. And when I divide by 600, what do I get?
9.2.
Thank you, 9.2, and that's percent. Right, Allison?
Yes.
Yes. All right, last one. We have a money market, which is again also kind of like a savings account. We have $158.40 that we're making on a principal of $1,200. So we'll set it up the same way. $158.40 over 1,200 equals R over 100. And we'll cross multiply. So this So 1200 R equals 100 or 15,840. What's the interest rate?
13.15.
Okay, so we found all of the interest rates, which was exactly where we were heading in the problem. We haven't quite answered the problem yet, though. The question actually asks which account paid the best annual interest rate for 1 year. What's the answer to that? The third one, right? So it's the money market. The money market paid the best interest rate. Does that make sense?
Could you also enter it into the I equals PRT formula?
Mm-hmm. Yeah, you'd get the same answer. And you could, because it has, we're comparing the annual interest rate for 1 year on it, which is why both of these methods both work, because it's the 1 year business.
If it was more than 1 year.
We'd have to figure out if it was compounded interest or simple interest, and then we'd have to use the appropriate formula.
Oh.
Yeah. It becomes a lot more complicated if we're dealing with more than 1 year.
If it was saying that it accumulated the following interest for 1 month, and then it asked for which account paid the best for the year, would you just multiply those by 12, and then that would give you it?
Well, if you're only going to, if you're comparing all of them over the same time frame, it doesn't really matter, because they're all doing the same time frame. So if we're still looking at looking at a monthly interest rate, and you found an R value for a month, yes, you would multiply it by 12 to get the R value for a year, but the comparison would still go in the same direction.
Right.
So if it was more for 1 month, it'd be more for 1 year. So that's actually how that would work out. All right. This one does not quite look like an interest problem, but it actually is. Let's take a look at it. This one says, if a publishing company signs an agreement to allow a textbook, where the first edition has 500 pages, to expand over several editions till it's 1,000 pages. The book is growing at approximately 10% in the number of pages over each edition. The question is how many editions could be published before it reaches the contractual limit. So when this language, contractual limit, that's the 1,000 pages it's talking about. Because they've described this in such a way that once it reaches 1,000 pages, the contract's over. They may or may not continue it, but if they did, they'd have to have a new contract to do that. Do you guys understand what's going on with the problem? Okay. So let's just think in terms of what's happening the first year, and then we might be able to generalize an equation to what's happening in general so that we don't have to continue the process for a number of years. And so the first year, or the first edition, has how many pages? 500. And it's telling you that it grows at a rate of 10% per edition, right? So the rate is actually 10% growth rate. It's like a 10% growth rate in your money. Okay, it's just doing it in pages instead. So let's just think what that means in terms of the second edition and process through that if we wanted to, we could continue this process indefinitely. What in the world would I do to get my second edition? Yes, so your suggestion is to take 500, multiply it by 10%, which is the same as the decimal point 10, and add that to the 500 that I started with. Does that sound right? Okay. Yes, we can do that. This is actually using the simple interest rate formula. You're actually using it. The P is the 500. The R is the 0.10, and while it's not actually written there, the time is 1. So you're using it 1 time to get this to happen. Make sense? So this actually ends up being how many for the second edition? 550. Now, could we continue this process for the next book, the next edition of the book? Absolutely. But I won't add 50 pages for the next book. What will I add?
10% of 550.
10% of 550, which would be 55 pages, right? I'd be adding 55 pages. So let me just write out what you just told me for the third edition. So I'd actually take the 550, which is the current number of pages, multiply by 10%, which you guys just said was 55, and I'd add it to the 550 pages that my book had from edition 2. Yes?
Could we just multiply it by 1.1 instead?
Yes, you can. I was going to get there next, but you're ahead of me. Very good,
Sorry.
Caitlin. No, you're fine. I'm going to show you that. You betcha. What does this end up being? 605. All right, good. All right, so this idea of multiplying and adding works, and there's nothing wrong with it, but there's a shorter way to do that, as Caitlin's pointing out. And I don't think anybody's ever pointed that out when I've actually done this problem, so you should get a gold star for the day. That's awesome. This actually could be done easier if I just took the 550 and multiplied it by 1.1. I'm sorry, the 500. This next one was 550 times 1.1. So why in the world is multiplying by 1.1 the same thing as multiplying by 0.1 and then adding the original number back? Any thoughts?
Because you're taking the whole and then also the part of the whole.
Yeah. This number 1 at the beginning here is the whole. That's what gets you the 500, the original 500 pages. This 0.1 here gets you the 10%. The other thing you can think about is that 1.1 is the same as 110%. So you're getting the 100% of the book pages plus 10% more. So you don't have to do it that way, but it's nice because it does it in one step instead of 2 separate steps in your calculator when you're working it. So that's actually very friendly. But notice what actually happened here. Every time I do this, I've got to continue the process with a new number, don't I? The number changes. So this is not simple interest. Because in simple interest, you use the same principal value no matter how many years, or in this case, editions of the book that you were using. So this isn't simple interest. This is actually what? It's actually compound interest. Okay, now I know it's not really interest, but just bear with me while I keep using that terminology. It's definitely compounding instead of simply, increasing. So if we actually take a look at that compound interest formula, what is that compound interest formula? Can you guys tell me? A equals what? It's got a P in it. What's next?
1 plus R over to the NT.
Exactly, to the NT. So let's identify the pieces of what this would be with the context of this particular problem. What is the P, or the principal value, in this particular problem? That's the 500. It's how many pages that I originally start out at. What is the R value? That's my 0.1. That's that 10%. Do you know what the N value is? It's 1, because it's doing it every edition. We're not doing it, it's not like we sort of turned in the edition and then we got it back and we did it twice. Okay, it's not increasing twice every time. So this is the value of 1, and so this value is 1 as well. And then the time is what's changing every year. So let's take a look. I'm going to simplify all this because it looks like a lot of mess right now. If I take 0.1 divided by 1, I get 0.1, and I add it to the 1, I get the 1.1. Does that 1.1 look familiar? Caitlin showed us that one, right? And then this exponent t. Well, this exponent t then can work for any time that I want it to. So let's go back to the question. This is how this book is developing. This is the book's page count. That's what we have found, is the number of pages each edition will have. And the t in this case is the number of the edition. Okay? And that's not actually quite true. How do I want to write that? Because your first edition is actually when t equals 0.
So would it be the edition number?
It-
No, because if
It's not quite. Yeah, it's related to the edition number. So if t equals 7, that's actually the 8th edition. Right? Because t equals 0 is actually your first edition. It's off by 1 is what's going on there.
It could be like t minus 1.
Yeah, so you could say something like, another way of writing it is where, let me say it the way you did. T minus 1 is the addition. Is it t minus 1 or is it t plus 1? Plus 1. T plus 1 is the addition. So whatever the t value is, you add 1 to it, and that's the addition number you're on. Okay, so let's go back to what the question's actually asking. Now, the question asks, how many additions could be published before it reaches its contractual limit. What that means is that you can continue to change the value for t indefinitely in your calculator until you actually exceed 1,000. That's what you're looking for. So if you plug into your calculator this expression, 500 times 1.1, and then you use the little caret button raised, or your y to the x button, depending on your calculator, raised to a power. So we know it's not the first addition, the second addition, third addition. We did those by hand. So you want to try something somewhat larger. So somebody give me an example that you could try. Don't go crazy here.
The 10th edition.
10th edition. Okay, put in the 10th edition. Let's see what happens. What happens when you put in 1.1 raised to the 10th power and then multiply by 500? I don't have these answers written down because you guys are picking my t values, so you're going to have to tell me what you get. What'd you get?
1,296.87.
So that's actually too much, right? I mean, it's more than 1,000. So we're not quite sure at this point, is that the right value or maybe one less? So let's do the exact same thing and raise it to the 9th power, right? 9th doesn't work. What happens when you did it to the 9th?
I already made it go away. It was like 1,178.
Okay, so that's still too big. Is that what we're hearing? 7th edition works. So when you did 7, what did you get?
974, like 36.
Okay, so let me write down what you're saying, Hannah, just a second here. So you're saying that when I plug in the number 7, what do I get? Approximately. We need a whole number because this is the number of pages of a book. So write me a whole number.
Then 974.
974. And if you do 8, it's too big, right? So this is the t equals 7. So what edition is this of the book? It's the 8th edition. So if I were to try to publish a 9th edition, it would reach too high in the page count to be within the contractual limits of this policy that we have set up.
I have a question.
Mm-hmm.
So the answer comes out to be 974.35855.
Yep.
Would it technically, since we're talking about pages, be 975?
You could if you'd want to write it that way. It's not a big deal to me.
Okay.
I don't care.
Okay.
Yeah, I'm not going to be worried about your decimal rounding at the end on that. It's not part of the answer. You're just using it to establish your answer anyway.
Okay.
So it's fine. Either way is fine. Okay, any questions? See, it was an interest problem, wasn't it? At least sort of. All right. Here's another fun one. Because of a recent recession, the value of new houses depreciated 10% each year for 3 years in a row. You know, this happened not too long ago. Like literally everything tanked. You guys probably didn't even know it happened. It didn't happen near as bad in Oklahoma as other parts of the country. But housing prices just went way down. So this is what's happening in this problem. We have housing prices that go down 10% each year for 3 years in a row. And then after that, they are going to increase in this particular problem 10% per year each year for 3 years. The final question that they're actually asking is, based on that information, did the value of the house increase or decrease in that 6-year time frame? And you might be tempted to say that it stayed the same. Decrease, 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 increase, increase, increase by the same amount. But we're going to take a look and see if that happens. Now, there's nothing in this problem that tells you how much the house is worth. Agreed? So what we're going to do is we're going to make up a housing price value in order to actually do the problem. Because the housing price value we're going to look at is just going to be a comparison to what we started with to what we ended with. So it doesn't really matter what we start with. We're just going to be comparing the first and last. You guys following with me? So I'm going to suggest that we're going to let the house be $100,000 because that's a reasonable number for a house price, first of all. And it's a nice, beautiful, whole, fabulous number to work with. I like all the zeros. Do you? Yeah. Okay. So we're going to let our house be the original price of $100,000. All right, so what we're first going to have the first year is a decrease. Now, I'm going to show you how to do it again by hand, and then we're going to look at it in terms of a formula to establish as well, so because you can think about it either way. Either way works. this is decreasing and increasing both times with 10% as the rate. So if this decreases by 10%, what's 10% of 100,000? 10,000. So what we're really going to have is we're really going to have that original 100,000 minus 10,000, which is 90,000. What's going to happen on year 2? 10% of 90,000, so we're going to start out at 90,000. What's 10% of 90,000? Well, first it's 9,000, and then the result's going to be 81,000, right? Yeah. And then year 3, if this happens again, what's 10% of 81,000? So what is that if we subtract? Anybody know a shortcut way that I don't have to do this subtraction every time? Multiplication by 10% and the subtraction every time?
Can we do the thing that you just did with that PT?
So what would we do with our 100,000?
Multiply it by 1.1.
We would if it were increasing by 10%.
Negative 1.1.
No, but you're thinking along the right lines.
Like 0, 0, 1.
No. How about 0.9? Where'd 0.9 come from? What is 0.9 as a decimal or as a percent? What is that representing? That's representing 90%. So I had 100%. I took away 10%, so that's 90%. So you could do this with percentages instead and multiply by 0.9 every time. That would do all of this in one step each time instead of 2 steps. So we could do 100,000 times 0.9, then 90,000 times 0.9, and then 81,000 times 0.9. The other thing we could do is we could jump straight from the original to year 3. How could we do that? Well, we'd take our 100,000, we'd multiply by the 0.9, raised to the 3rd power. And that's the compound interest that's doing that, just like the last problem. Because that's the only thing that's happening every time is I'm multiplying by 0.9. So you multiply by 0.9 3 times, you get the value at year 3. So either any of those ways is perfectly fine. It doesn't matter to me which one you like. You just pick your favorite, okay? The housing price at the end of 3 years is $72,900. But as the market recovers, it recovers from that new price, $72,900. So we're going to start at the $72,900 before we do as we do our increase in the price. So we have $72,900, and this is at year 3. And we'll go through year 4, year 5, and then we'll end up at year 6, and then again we'll talk about other ways to do it. If you do this with an increase, $72,900, you could do this at this price plus 10% of this price, which would be 0.1 times $72,900. Or you could do this as the $72,900 times what? 1.1, just like on our last problem with the books, right? Either of those methods will give you the same value for year 4. What will it give you? What do you get for your year 4 value? Anything?
80,190.
Did I get that written right?
Yep.
Okay, good. And we could do the same thing again for year 5, right? So we could either use the 80,190 plus 10% of 80,190, or we could take the 80,190. Well, you got to get the 90 in there first. Okay, and then times 0.1, or 1.1, excuse me. Again, either way you do it, you're going to get the same value. What's your year 5 value? Look good? And then we could do the same thing again for year 6, 89,209 plus 0.1 of that value.
It's 88.
Yeah.
88,000 here?
Yeah.
Okay, thank you. Or we can take the 88,209 times 1.1.
97,029.9. So 97,000.
We can have 90 cents, so that's okay.
Oh, yeah.
Yeah, that's all right. I mean, that's an awkward house price, obviously, but in terms of the computational ability, we can do that. How could I have jumped from year 3 down to year 6 without doing this 3 times in a row?
Multiply it by 1.1 to the third.
Yes, you could have. We could have taken that original starting value, which is the new principal, 72,900, and multiplied it by 1.1 to the third. And we would have gotten the same thing, $97,029.90. Now, I want to take a look at that particular value and talk about it. First of all, let's ask the question of what it's looking at in this problem. The question actually asks you, did the value increase or decrease in 6 years? It decreased. This is less than it was when they first bought the house, right? Yeah, definitely. And then it says explain. Well, the problem with the word explain here is that everything that we've written down so far was hinged upon the house being $100,000, which is something we made up. Do you guys see that? I mean, we can definitely say it lost value, and that would have worked no matter what. We can't really identify what we've done so far about how much value it lost. So let me show you how you can identify how much of the value it lost. Somebody do the subtraction for us real quick. What happens if you take the 100,000 and you subtract that 97,209.9 or 90 that we got? How much did we lose in our example? 2,970.1. Because this is the money we lost. Okay, the money that we lost, 2,970.1, over the original price of the house that we created, can be written as a proportion that allows us to figure out how much value we lost, and this will actually take the $100,000 house out of the question. It eliminates the fact that we're considering a $100,000 house. So these proportions that we've been setting up will work here as well. So let's take a look at the cross multiplication here. I have 100,000 x equals 297010, so 297,010 divided by 100,000. What is the x value? What do you get?
2.9701.
Okay, and we'll go with 2.97. The 0.1's getting a little bit technical down the very end of our decimal expansion, so I'll just leave them off. This is the decrease in the value of the house. If you did this problem and you had chosen a house that was $150,000 and you went through all of these steps, everything would have been different. Your answer would have said that, that the house decreased in value. But when you figure out the percentage it decreased by, you would have also gotten 2.97%. And it would work out the same way at the end. Okay? Because that right there takes out the $100,000 from the consideration by doing that proportion setup. Any questions on that one?
Would your answer just be decreased by 2.97%?
Yes, it would. Yeah, and if you do the explanation, you would talk about, the fact that you calculated the original value, calculated sort of the year 3 value and the year 6 value, and you compared them using proportions. Mm-hmm. All right, any other questions on this one?